So we're going to start with number 10. So again, I'll just pause this recording. If you guys have questions and I just record the whole hour, then I will. If not, then I'll just pause, unpause, so on and so forth. So we're starting. So this is quiz review. Oof, my handwriting is not on point today. I'm going to have to work on this. Number 10, you said. So yeah, this is the hamburger hot dog problem all over again. You know that, right? You recognize that, I'm sure. So you first have to choose which one you want to be your X. And I phrased it the same as the one in your homework, so as to hope that you would not pick burrito. Burrito would be the worst one you could pick. Did you pick one?
Oh, yeah.
That's a good choice. So we're going to let X equal the cost of a taco. And then you know the drill. Now we need to define the cost of some nachos and the cost of a burrito. So how much would the nachos cost? Sure, that's fine. So let X plus 85 equal the cost of nachos. And then what the tough one, as always, is going to be the burrito, because the burrito is not directly related to the taco, but rather it is directly related to the nachos. What would you say about that? And how did you come up with that? Yeah, but you're right. I mean, the nachos, basically the advice I would give anybody here is when you're doing the problem. So the problem says, nachos cost $1.35 less than a burrito. And there's a science to this. And basically, like if you took your pencil and lightly scribbled out all the stuff that has to do with the taco. So if you scribbled out starting at 85 cents and you scribbled out all the way through the word and, then you would just see that sentence that I have on the TV, that nachos cost $1.35 less than a burrito. So you can directly draw a relationship between the burrito and the nachos. And since the burritos cost $1.35 more than the nachos, and the nachos already cost 85 cents more than a taco. You're exactly right. So we have to add 135 pennies to the cost of a nacho. And adding that is exactly what you said. So that's going to take us then to X plus 220 is the cost of the burrito. So not if, but when you see this problem or something very like it again tomorrow, scribbling out part of the sentence when you go to do the hard variable is probably a good idea, because it allows us to, again, draw the relationship that we need between one item and the other item that we're looking for. So you're good to hear because you came up with this on your own, right? Okay. So what we're going to say now from here is, well, we have to, I wonder if I can just delete that. Nice. So now we have to write an equation, and I would strongly encourage you to use words before you use math. I know I've said that now like 30 times. So I would write it down as, okay, so 3 burritos cost. And when it says cost, that means equals 15 cents more than 2 tacos and 2 nachos. Are you comfortable with that sentence? It's not all words, but it's just enough words that we are not intimidated by it. Like it should make logical sense that that's the way it goes. You good with that? Okay. So now it's time to put mathy stuff in. So where it says burritos, we're going to put the X plus 220 that you came up with. So we have 3 packs of X plus 220 cents equals 2 packs of just X plus 2 packs of X plus 85 cents plus 15 more cents.
Yeah, it was only really that part.
Writing the equation? Did you use words? That's why you didn't understand it. And one of these days, like all my ninth graders are going to trust me enough to say, I'm going to try that trick with using words. I think we steer away from it because it just feels like extra work to us. But honestly, it really is worth it because it allows you to take, I mean, assuming you know how to read, which I know you do, it allows you to take the words that you understand in your brain, transfer them to paper, and then that becomes like the middleman. And then you use that then to lead you to the bottom equation on the board. So when you solve this equation out, I'll walk through it with you here. Bear in mind just at the end that the answer that we get is going to be in terms of pennies, which is what I did too. I thought using decimals would just be a pain. So I just, like you, turned them all into pennies. And then at the end, I'll turn my answer back into dollars. Because like you're not going to go to a taco stand and say like I'll have a burrito and they're like, okay, that's 576 cents. So that's why we'd reconvert at the end. Would you like help with the solving process, or do you think you want to walk through it?
Sure.
Okay, so on the left, I hope you agree, we get 3x plus 660. And on the right, when we distribute the 2, we get 2x plus 170. And then we're going to add the 15 cents at the end. And then, of course, we have a ton of like terms that we need to combine before we start actually solving the equation. So on the left, we're just going to leave it at 3x plus 660. But on the right, we're going to put our x's together to make 4 x's. And then we're going to put our pennies together to make 185 pennies. And from here, the flow ought to be kind of ingrained in you. That's one of the goals before you leave this year, is to get you to just solve equations 100% well, but 100% quickly and efficiently. So I'm going to pull the 3x over to the right to just give me positive 1x because, well, that makes sense. And then I'm going to pull the 185 to the left, leaving me with 475. So that's the cost of one of the items in terms of pennies. So we would agree that like we could draw a little arrow off of that and say that that's the equivalent of $4.75. You would agree. Good.
Mhm.
And that's the cost of a taco. And the problem says, how much do they all cost? And so I would switch colors now and say like, okay, I'm preparing to write my final answer. So I could say like a taco costs $4.75. And if we just go down our variable declarations in order, logically, the next one we'd want to find would be the nachos. And how much would the nachos cost? Are you struggling with the math or what to do?
I'm trying to
With what?
the math.
Okay, so it's $5.60 because you just have to take, I mean, understand why we declare variables. If I scroll back up and look, I know because I wrote it down and you wrote it down too. You and I both know from right here that nachos cost 85 cents more than a taco. So if you know that a taco is $4.75, you can just add 85 cents to that. And then you 100% will have the cost of the nachos. So if you wanted to do it on a calculator, you could type in like 475 plus 85, or you could do like 4.75 plus 0.85. Again, I don't care. You just have to be consistent. Dollars have to add to dollars or cents have to add to cents. I don't care. But either way, it comes out to 560. You okay with that?
Yeah.
So then nachos have to cost $5.60. And then that leaves us with the burrito. So we could say a burrito costs. And again, just go back up to your variable declaration. Like you did all the hard work. So reward yourself by using the declaration. You got up at the top of your paper. You know that a burrito is 220 pennies more than a taco. So just take your cost of a taco and add 220 pennies to it, or $2.20. Again, I don't care how you think of that. What does that come out to be? So that would be my answer that I would proudly display. And again, if I had phrased that question differently, which I could have said, just hypothetically at the end, I could have said, how much would 4 tacos cost? You got this. You just take your answer and multiply by 4. If I had said, how much do 3 orders of nachos cost? You could just take your nacho cost and multiply it by 3. You can answer any question once you know your base. If you know X, you can answer literally any question about those items. My question was really generic. Just how much does each one cost? 11 is going to be an age change problem. So we know we're going to have to define 2 sets of variables on this one. So I'm going to start by defining just the right now. So who would be your X, Duke or Sandy? For sure. So we're going to let X equal Sandy's age. And you probably want to be specific and say like now. That's important. And then what is Duke's age? Mm-hmm. And then I'll draw like a little dividing line here because I'm switching time. I'm going in my word problem time machine and I'm going into the past. I know that because of the words 15 years ago. And I have tried to say this to everybody. The trouble is not everybody listens all the time. Like when I'm explaining something to you, there's probably 7 people ignoring me. And that's okay. If you read past those words 15 years ago, you'll miss the problem. Because not everyone, a lot of people think that what it says after that, like, oh, 4, I got to put a -4 in there. And that's nothing to do with anything. All I care about is that I'm going back in time 15 years. That's it. So you stop reading. What would Sandy's past age be? At some point, I'm going to care about what it says after 15 years ago. Right now, I don't care. I literally could not care less. I just want to know the -15s. What is Duke's past age?
Would you,
I'm going to write it in white for you up here in the corner. No questions asked. It will always be the same process. You take Duke's current age, which we know. You told me it's X plus 13. And since I'm going back in time 15 years, I literally just attach a -15. That is Duke's age 15 years ago. Now, would I clean it up? Yeah, totally. What would that become? X minus 2. Right. So I'm now saying that X minus 2 is Duke's past age. So the variable declaration step is over, and now it's time to read past the words 15 years ago. Now I care. I want to know, what is this relationship that was true 15 years ago? So it says, and again, I'm guessing you didn't use words, but I believe that it will help you. So I'm going to just write it down, and I'm using words. Duke's past age here it goes, was, that's my verb, that's my equal sign. 4 years less than, so I always want to put that minus at the end because less than and more than go at the back. So 4 years less than twice Sandy's past age. Do you 100% have faith in that sentence? And it's just, I mean, I think it's irrefutable. I think if someone didn't understand that sentence, I'd have a hard time explaining because I just feel like it's like just what it says, like it's just there. And now I'm going to put stuff in place of words. And so where it says Duke's past age, what am I going to put? What am I going to change that into? Right? And then I'm going to put 2, and then I'm going to put parentheses. And what am I going to put in place of Sandy's past age? Right? And step 2 is officially complete. Step 3 by November 9th, today should be an absolute walk in the park. We're distributing, combining like terms, things we have done hundreds and hundreds of times. You and I should both arrive at this crossroads right here. X minus 2 is the same as 2x minus 34. And then from here, again, the equation really ought to just almost solve itself. Pull your x to the right to keep your x's positive. Pull your 34 to the left, switch it to plus, and you'll figure out that x is 32. And again, no one cares about x. No one would look at the board and have any idea what that even means. It's up to us now to inform the reader what ramification, what implication, what does this mean? Well, what is x? And the problem says, how old will Sandy be 20 years from now? So if you think about it, I could draw a little arrow here and say, so this is Sandy's age right now. So it seems like a random question, but I alluded to this a while ago that I might just start asking you random questions, and I could ask you anything. If you know Sandy's 32, the question is, how old will she be in 20 years? How old will she be? Done. So you just make an answer box, just say something like, Sandy will be 52 years old in 20 years. I hope that made sense to you. I'm so glad. What's up, Seabass? Okay. Yeah, I'm not surprised. I thought this morning that I should probably go back and recheck all myself. Would you like to go through it? Great. Mhm. Let's. Did I brain fart? What a dork. I did that? Well, listen, you guys are two of my most trusted students, and if you're telling me I screwed up, I'm going to own this one. So I'm going to work through it with you right now. I'm not even going to look at my answer key. I'm just going to start over and catch my boo-boo. And then I'll leave it up there and see. Maybe I'll put a little. I'll put a little. I'll put a little comment on there like, oopsie. No, I'll probably fix it and re-upload it. So, but I appreciate that. That may not be the last mistake you find. I thought to myself, if I typed this up yesterday and didn't make any mistakes typing it, I thought, oh man, I dodged a bullet. And if I somehow made it through without making any mistakes, that would have been 2 bullets. So, yeah, hopefully this will be the only mistake, but let's work through it. So on number 9, it says that they weigh. I don't need that information yet. So my x is probably, we agree, going to be Steve. So let's let x equal Steve's weight. I assume you guys both agree with that, right? Okay. And then from there, if I had this problem to do again, I would define Mary next. I would say that since Mary's 26 less than Steve, that Mary's going to be x minus 26. And then finally, Norm weighs 33 pounds more than Mary. So I'm going to do, so off to the side here, I'll do a little bit of work. I'm going to take Mary's weight, which is x minus 26, and I'm going to add 33 for Norm. And that should be x plus 7. Are we all in agreement to this point? Okay. So I just made a little algebra error. That's awesome. So I'm going to say that the 3 of them added together weigh 473 pounds. So I'm going to say that Steve plus Mary plus Norm is equal to 473 pounds. Everything's still looking correct. It's here that I made a boo-boo. So I'm going to combine my x's to make 3 x's, and then I'm going to do negative 26 plus 7, which is negative 19, equals 473. Still good? And then I'm going to add 19 to both sides. Did I subtract 19? I put what I do, 429? Holy smokes. How rather dyslexic of me. Perhaps I have a little bit of undiagnosed dyslexia. Yeah, to totally be 492. I actually put 429. I was going to say you can't prove it, but well, it's on the internet, so I guess it's provable. So I'll go back and fix that. Thank you for catching that. So x, of course, then equals 164, I believe is what that would come out to. Is that correct? Okay. Thank you for that. Good catch, you guys. Thanks. Keep finding my boo-boos. So 106. So at this point, I'm done. I just need to say, oh, what does it ask us for? Oh, so if all I need is Mary, I just do 164 minus 26, and I should say that Mary weighs, don't put weight, ding dong, weighs, what is that, 138? Good. Is that what you guys got? Alina, is that what you got? 138 pounds for Mary?
Yeah, I don't know.
Nice. Thanks, guys. Good catch. Did you find any other ahronisms on there?
I think it's I got like.
Good. But was it the one that I missed? So like it wasn't.
No, it was a
But you're better now? Good for you. So you're going to have 25 minutes of free time here. So feel free to occupy your time how you wish. I don't. You'll turn in these practice quizzes with your quiz tomorrow. So everything else by then should have been in. Assignments 13 through 19 should be done in the grade book. As I said before, those of you that are all caught up, that feels nice. Those of you that aren't, I know it feels bad. But you've made the bed. You get to sleep in it. And so get your work done. You've got a lot to do in 23 hours and 32 minutes. All right. So I'll answer more questions if you want. Whatever you need. Eventually, I'm going to fix my answer key and I'll rescan it and re-upload it. It's tempting to leave it there, but that would feel bad for someone at home grading. They'd think like, "Oh, how did I do wrong?" So I will fix it and rescan. Any questions in the meantime? You all caught up? Okay. Roger that.